Hello and good afternoon. Not to sound like an airline, but I know you have lots of options of where you can be. Thank you for being here. We're going to talk a little bit about network attack simulations today, but we're going to have to start that off by looking at some CVE data. So there are about 28,000 vulnerabilities published last year, which is quite a number. And kind of the easiest way to start looking at prioritization there becomes the base severity. If you're not familiar with CVSS, right, you have a number of components, things like the attack vector, the confidentiality impact, et cetera. You choose values for those. Once you have values selected for each one, right, you calculate that up. You get a base score between 0 and 10, and that correlates to a base severity. So if we look at the high and critical, that CVSS base score is falling between 7 and 10. And for many organizations, this becomes kind of the default way to start prioritizing. However, if you used just that method, you are still looking at 15,000 vulnerabilities last year, so good luck. So we often look at some other things. For example, the CVSS attack vector. Again, if you're not familiar with CVSS, right, this is where a vulnerability could potentially be exploited from, right? Network being, if you'll forgive the oversimplification, the open internet, all the way down as we shrink the diameter to physical, where you need actual physical access to that device. If we look at vulnerabilities that have a high or critical severity and a network attack vector, we see a graph like this. I realize it may be hard to tell. The purple is the ones that are high or critical and have an attack vector of network. The more bluish one is not network. And you may say, that's actually kind of small. I'm not really sure what happened last year, because if you look at the average over the past 5, you hit 75% of vulnerabilities that have a higher critical severity are exploitable, at least in theory, over the network. If you look at the little algebra that you have to do to get the base score from your CVSS components, it makes a lot of sense. The network vector is a huge part of this calculation, and for good reason. There are many other ways that organizations look to prioritize vulnerability remediation. One of them being the CVSS environmental score. Many of the same components, right? But you, as an operator, as an analyst, rescore them. You say the vulnerability is reported to have a high confidentiality impact, but I know my network, I know my system. I'm going to say the impact is low. That can be very useful. However, it requires a very high degree of confidence by your analyst to be able to say that, and not all organizations have that maturity. You might also use this as a KEV catalog. I love the KEV catalog, right? To not just say, we think this might be exploited, this could be exploited, but to say we are seeing active exploitation in the wild. You should maybe get on this. Finally, the exploit prediction scoring system, right? Looking to get a probability value for how likely something is to be exploited. There's actually been a lot of university research in this space looking at predicting exploits, and I'm glad that some of that has made it closer into industry. However, none of these actually get us to the real question, which is, but am I at risk, right? Are they in my network? Vulnerabilities in my network? Right. So here I am to talk about network attack simulations, and specifically the VENT project. This is some DOE money that came as part of an industry-academia collaboration with the University of Arkansas and the University of Arkansas at Little Rock, 2 vendors and a utility. Now, the utility is not named on this slide just for privacy reasons, but we do have one who's been helping us quite a lot with testing. If you're not familiar with the vendors, I'm not a salesperson, I'm not here to sell you something, but just quick rundown, right? Bastazo, looking at vulnerability management in electric utilities, particularly in the SIP7 space. Network perception, read in your firewall rule sets, and build you a graph model of your network. This is a 4-year grant. So just to give you some expectations, right? These are a static analysis. This is not, we're not scanning, there's not sensors here. Low cost, with time, computationally, right? And I mean, ideally, money, right? But the idea is that these could run very often. They don't take a ton of time, they're not overly burdensome, they're not running on a supercomputer or even a GPU. What they are not, it's not a network scan, it's not a pen test, and it's not virtual reality. Like I'm saying simulation, but we're not the Matrix, we're not beat sabering away the adversaries, right? We are running some static simulations. So we have 5 main steps here, and we are gonna stay on a somewhat high level. I only have so much time. First, we have to find our assets and vulnerabilities. We need to identify network protocols associated with those, obtain a network model, do an adversarial analysis, and then actually run the simulation itself. So I know you were all hoping, but I'm not here to tell you that we've solved the asset management problem. If you thought you were expecting that, I would ask, well, what abstract did you read? But we can do quite a lot with a static asset list in the SIP space. I mean, you're going to have at least something, right, that you give to NERC when they come knocking on the door. Given the vendor and product, we can do really quite a good match with the CPE in the field in the NVD, even given its limitations, and believe me, I am aware of its limitations. We can also take results from a vulnerability scan and infer the assets from that. So take the vulnerabilities that you know about, take your assets. There's also some degree that we can do this with the network graph model, right? You're not always going to list out individual IPs in your network rule sets, but there may be cases where you need to, and in those cases, we can identify those assets. Now, I'll give you a caveat here that this is not perfect, right? But the goal of this grant was not to get everything, it was to get better security with what we have. There are many, many people working on how do you find all of the assets, how do you make sure you have every vulnerability, and those are great and noble goals, and I will acknowledge that this does not solve those problems, so please don't come ask me why we didn't find everything. The second step then is to identify network protocols. If we're going to look at what vulnerabilities might be exploitable over a network, we have to have some idea of how, right? Using vulnerability descriptions, we can often grab information about which protocols are being used and correlate those with ports. This is not a vulnerability in RDP, right, in the protocol, but it's a vulnerability in an application that implements it, and if it's going to be exploited, they're going to connect using RDP, right? We can use this, we can use our network model. We've been using natural language processing and machine learning. It was to somewhat to my surprise that actually some of the large language models can do this quite well. I will admit to being a skeptic of large language models' capabilities, but they have done quite well with this, with validation. Then we look at getting a network model. I will fully admit I took this image from Network Perception's website because I didn't want to make one myself. Again, I'm not here to sell you something, but I do want to make a point here on the industry-academia collaboration piece, which is that we don't have time to reinvent the wheel. There's a lot to do. The point of this grant was to look at modeling vulnerabilities within a network and being able to build off of, in this case, Network Perception's network modeling from firewall rule sets and Bastazzo's ability to pull vulnerabilities for assets and build on top of that. Like I said, I'm not here to sell you either thing, but that's where this comes from. And then we start an adversarial analysis. We look at 3 main things, right? What attack complexity can they achieve? What privileges might they have? And what exploit maturity do we imagine that they have? Not imagine, can we infer that they have? These become customizable, right? we can say that we think a botnet has different capabilities than a ransomware group. These change over time. We can track reports about threat actors, adjust these as needed. Now, I will say, these are determined on the adversary level, not per vulnerability. If we were to do this per adversary, per vulnerability, we'd hit the same problem. We don't have time for that. On some level, we have to make assumptions, right? And this is one of the ones that we make. With these simulations being of a low time cost, a low computation cost, the idea is that we have the ability, when there's some uncertainty, do we think the attack complexity capability is high or low? I don't know, run both. Maybe the results are similar, maybe they're not, right? But we have the ability to do multiple things. We can actually start to track news reports as well. We've been working on this with different ransomware groups, seeing what sectors are hit, right? What are the outcomes of those attacks, and adjust as needed. And then we do actually the simulation itself. All of these beforehand were lead up, right? This is what we need. So we do kind of this looping reach analysis and safety analysis. You start by placing an adversary. You say, we're going to place it in an external IP, and we're going to look at what can it reach. We're going to find the assets that it can reach. And then we're going to say, what's the safety analysis? Can they exploit? Can they get into that asset? Can they use that asset to pivot and move further into your network? And we're going to repeat that. We're going to go through, can they get to another subnet? Can they see another subnet? What if we have a VPN? What if we have a firewall? Are there exploits on these middle devices that they can use to get further into your network? What protocols and what ports are those vulnerabilities using? Are those ports allowed through your firewall rules that we have because you're using your firewall access lists, right? When we get to the end, when we've kind of exhausted the reach of our imagined adversary, we do an impact analysis. Say, what were they able to do? What level of harm were they able to achieve? Looking at, have they made a foothold in your system, right? Did they hit a wall and kind of had to back out because we couldn't go any further? So like I said, we're considering exploits along the way in these middle systems. We're considering user interaction. That's an important piece. If a vulnerability requires a user to download a maliciously crafted PDF and your device has no user login, okay, that's going to be kind of hard. That's an important piece of looking at this, although I would say, why do you have software that accepts PDFs on a device with, but that's a different question, right? That's a different question. We're not asking how we got here, we're asking what we do about it. We're starting to look at credentials. What if they had Active Directory credentials? How far could they get, and where could they go? I realize this is high level. Again, I don't have all the time in the world. Actually, I should say this at the end, but I'm here, and then two others from my team and a couple from Network Perception will be here if you want to come grab me. So we get to the results, and I'll explain this a bit. So as far as the rows, right, we have the vulnerability. We get these features from the CVSS score. Attack complexity, what privileges are required, is user interaction required, what's the exploit code maturity. We know, based on asset features, right, back to that first step, if the asset itself allows user interaction, and then we have our modeled adversary capabilities. So we can start to compare these to say, right, does the vulnerability have a high attack complexity, but the attacker has a low capability? So here's where I have to actually explain part of this graph. So in the later three columns, right, where it has an X, that would be, by looking at these features alone, right, no privileges are required to exploit the vulnerability, but we can assume that the attacker has a high level of privilege, or the exploit code maturity is high. In a traditional kind of system, right, we would say, okay, well, that one's not safe. We need to go do something about it. in the case where we've run an attack simulation and we've said, hey, this exists, but an attacker can't get to it to exploit it, we can make a decision to call that safe. Okay, now, safe for now does not mean safe forever, right? It doesn't mean you shouldn't fix it, ever. It means that if you are trying to prioritize, you have limited resources, you cannot do everything, you're trying to address the threats that are coming towards you. This becomes a way to do that. This becomes a way to say we have places we need to focus, and this specifically, this vulnerability, is not one of them. When we look at remediations, we begin to have more options. We can say things like, is it easier to patch an upstream node? Does patching an upstream node actually limit attack paths for multiple vulnerabilities and multiple assets downstream, right? Can we mitigate the risk? Can we better implement a network architecture that segments things off, right? Being able to see that and not just see what your architecture looks like, but to be able to say, if we put something here, we could prevent exploitation later. Firewall rules, of course, always review your firewall rules. That's like step one. And again, not exploitable now does not mean not exploitable forever. Attacker characteristics change. Vulnerability characteristics change. Your network changes. The whole point of this being that it doesn't take very long to run, the whole point of that is that we can continually try this and see how the results change when these characteristics change. When you're, I want to put a caveat, not a caveat, but I want to put a sidebar in here, because I sit in the electric sector. I deal a lot with NERC SIP. When you're dealing with a NERC SIP audit, you may or may not know, you write kind of a little essay, and you say, this is our story of compliance. This is how I show you that we didn't just do this right. We have a culture of doing it right. We have policies and procedures in place to show you that we're doing it right, right? Something like this, not to brag on our own work, and that's not my point, but to say that not just are we looking at the patches that we have available, we're looking at the vulnerabilities, even the ones that we don't have patches for right now. We're looking at them constantly. We're getting updated information as things change within our organization, within vendors who are reporting vulnerabilities, and as adversary capabilities change. That becomes a way that you demonstrate your culture of compliance and also of security, right? That is actually my last slide. I'm happy to answer any questions. You will have to come to the mic so we can get things recorded for video later. Thank you all so much.
Hey, Kylie.
Hello.
I think that was a great presentation. I had a question about the adversary portion.
Yeah.
I wonder to what extent, as different organizations do this modeling or do this simulation, the adversary part of it needs to be bespoke for each organization, or if we could just have a pretty standardized catalog of design basis threats that some research organization or a SANS or a MITRE or somebody builds and maintains, and then kind of you can pick your option of high complexity or low complexity, high skill, low skill, script kiddie APT, and that's just that DBT on the shelf.
I mean, that would be it'd be incredible if only I knew people in the federal government. No, I don't. But no, absolutely. And right now, what we do, so all of this runs locally on their network. None of like the adversary, none of the entity data goes up into the cloud. But we have a cloud server to kind of gather information and then push that down to individual user instances, right? And then it can be modified or added to. So we say, we've been tracking this ransomware group, we've seen this characteristics, and if you want to say, I disagree, then by all means, right? But also, if you have, for example, some sort of information that's coming from an ISAC or a federal agency that I, as a software developer, do not have access to, right? You can add that. You can run that based off things that you know that I don't. And the ability to keep and keep it all within your network where you can have some degree of trust about it is key here. Thanks. Great. Here's my email. Please come find me if you have any other questions. Happy to talk more about this. Thank you for your time.